Hello everyone. I just wanted to record this quick video to go through the test that was written last Friday, maybe go through some of the common mistakes that I saw, and just generally take up the test. So, let's get started. So, question 1, we had all Java variables have a default value, so basically pick the correct default value for the various data types. So there were a couple of sort of common errors here. The first is a lot of people thought that the default value of string is an empty string, but in fact string is an object in Java, which means that it initializes to null. So this string properly connects to null. Int and short are both integer data types. A short data type is, of course, an integer that only occupies 16 bits instead of 32. Both of those initialize to 0. So int and short both initialize to 0. Let me just label this question A.1. There we go. And, of course, Boolean will initialize to false. So let's talk about question 2. Question 2 was, generally speaking, pretty well done. Dot 2. Basically, the only tricky part here was taking the following, int count a is equal to 6, and splitting that into 2 lines. That's how you do it. Boom. Question 3. Write a for loop that will print the following sequence of numbers. So, for loop, start int I is equal to 80. So you start at the first number. Then you our exit condition here, we're stopping when we hit 70, but we are including 70. So I must be greater than or equal to 70. I minus minus rather than plus plus, because the sequence is decreasing rather than increasing. And then, of course, you actually have to print I at some point in there. So common mistakes, forgetting the data type here. That was a pretty common one. And inverting this condition. Some people had I greater than or equal to 70, just because that's like how we see it very commonly. So, in general, I didn't think that question was done too badly either. So let's talk about question 4. Write a single line of code to read. So there was an error in this question, and if you didn't get the error in time, I was kind of generous. If you initialized the wrong data type, I was like, well, that was my mistake. So we have a so this string should say double, basically. So the solution, as I envisioned it when I put the test together, is as follows: double x is equal to new input dot next double. Some people wrote string x equals input dot next line, and some clever people said double x is equal to double dot parse double input dot next line, which takes it in as a string but saves it to a double, which is actually correct with respect to the exact wording of the question. Whoop. Correct with respect to the exact wording of the question. So there we go. Common errors included not including the data type here and including the line where you declare the scanner object. In this case, you didn't have to declare the scanner object. The scanner object was given to you. And again, be careful when the question says write a single line of code. That means write a single line of code. So let's move right along. Next question was about a while loop. So there are more approaches to this problem than the other one, but in general this was a good solution. Int I or x is equal to 1, while I is less than some value, say 7,000. Or you can pick the exact one if you want, but it doesn't really matter. Not only do we s out I, but we say I times equals 3. So a couple of points. You have to output the variable before you multiply it by 3, unless you want to start this guy at 1/3, because you need to print the 1 there, right? For some strange reason, I had a large number of people who were dealing with the while loop as if it were a for loop. So, for example, oh my goodness, I got coffee on my glasses. Terrible. That's what you get for a Monday morning, eh? Some people were taking this line and trying to squeeze it in here. That's wrong. Some people wrote a for loop and just called it a while loop, which is also wrong. So, you know. So, opinion, that question wasn't as well done. So, write Java for question 6, where you had to do the Java FX commands. So we had yellow circle, red rectangle. So first we set stroke color dot. Wait, let me look this up quickly. Yes. So an outlined yellow circle will set gc dot set stroke color dot yellow. I didn't take any marks off if you didn't include the gc dot. And then for the filled rectangle, which is red, gc dot set fill color dot red, of course, and then gc dot stroke oval with some parameters, and gc dot fill rect, which also has some parameters. If you got this far, then you basically got like a 3 out of 4 right there. So now things get a little bit tricky. The position that the circle should be drawn at is not actually specified. You get to pick it. So I'm just going to pick 0, 0. Now we specified that the circle has a radius of 100. Now what most people thought was that radius was the same thing as width, but it's actually not. The radius is half of the diameter, and the diameter of the circle is the width of the circle. So the correct values here are actually 200, 200. Furthermore, the top left corner of the rectangle must be located in the center of the circle. The center of the circle will be at 100, 100 if it's of width 200. So 100, 100. And then with a width of 300 and a height of 400. So these could be offset by any constant factor, so long as the proportion is the same, then everything was cool. Now, question 7, write 2 lines of code to create a variable of type foo. Very good. So this was basically, do you know how to initialize an object? Foo is the data type. Understanding that foo is a data type is an important step here. We're not given what the name of the variable is, so I'm just going to pick x. So we declare the variable without initializing it, and then we initialize the variable without declaring it, same as in the previous question, question 2. So new foo must be initialized with an integer and a string. Integer, string. Basically, initialized with means those are things you pass to the constructor. Good. So let's talk about question 8. Final question of section A. Implement a Java class named BubbleT. Okay, public class BubbleT. Single private integer instance variable bubbles. Private int bubbles. There we go. Include overloaded constructors, so you can set the number of bubbles or not provide the number of bubbles. So, public BubbleT, set the number int bubbles, or not set that. Public BubbleT, like so. So, so the sort of regular constructor proceeds about as much as you would expect. This.bubbles equals bubbles, but you have a couple of options here. So what I would consider the more correct solution here would be to say this and then pass the default value of 40 in. This is kind of the way that we covered it in the notes. But there was an alternative way to do this, which I decided was fine and worth full marks because it still works. Set the default value up here during class initialization, and then have this guy just kind of contain nothing. This, in theory, will also work, so I was fine with that as a solution, and this was by far the more used of the two solutions. So, good. Moving right along to application. One. I suppose I should get draw.io open for this, shouldn't I? This can be a little draw.io tutorial while we're at it, too. Delete. There we go. So, no, you stay hidden. Thank you. So, so we make our UML diagram here. If you got that far, that was worth 1 mark. Then we have our fields. So we have name, which is a string. And we have 3 more. The ordering didn't matter, but most people did it as in the order given in the question. Age, which is an integer. Height, which is a double precision floating point number. And smoker, which is a Boolean. There we go. Now, common error right here. A large number of people made these things public, but if we recall how we covered things in class, under a good object-oriented design, you make these private so that you can control access to them. For example, making the height public would allow it to be assigned to as well as read from, which it says in the question quite clearly that height is not, you can't modify height after account creation. Wow, it really just started raining quite heavily. Interesting. I'm recording this from the office, as you could probably tell. So we need a constructor. There we go. Now, if you'll notice, where is it here? include a constructor that accepts name, age, and height as arguments and initializes the user as a non-smoker. So that last bit doesn't come into it until we get to the next page. A common error I found with the constructor was that people would include the Boolean variable for whether or not a person was a smoker, when in fact that was not appropriate, as it wasn't called for in the question. So we initialize with a string, an int, and a double only. Let me just expand the... there we go. Now, we also need... So all values except the user's name must be accessible, meaning can be read, right? So all values, so we have getters. That's basically, we have getters for everything but name. So get age, returning int, get height, which returns a double, and get smoker. Or with Boolean variables, it's often often say is rather than get. But you know, it's 6 to 1, half a dozen to the other. It doesn't really matter. So we also need to be able to modify age and smoking status. So we will be able to set age int and set smoker Boolean. This line here, age can only increase, is actually not relevant to the UML diagram. That's a detail about how the method would be implemented, but UML diagrams don't care about how the method is implemented. They only care about what the interface is. So, also include a compatible method which accepts another object of the same type. So compatible accepts another Blinder account and returns a Boolean. It's not stated, but it was in the question, but that was a correction during the test, is that the return type here is supposed to be a Boolean, which, you know, I think is kind of common sense, but still it should be in the question. So there you go. There's your UML diagram for that one. Now, let's talk about the methods. So you, as the next couple of questions, you were to implement some methods relating to that class. So, for the constructor, remember, so this called for just the methods. You didn't have to like implement the full class. In fact, it said you do not need to implement the entire class right there. So, public Blinder account. We had a string name, int age, and double height. This dot name equals name. This dot age equals age, and this dot height is equal to height. And if you read the previous question, this dot smoker gets initialized to false. Basically, you had a mark for the headline. You had a mark for this bit, and one mark if you knew what to do with the fact that smoker is initialized to false. That was to B2A, B2B, the compatible method. So this was basically 5 marks for writing an big if statement and wrapping it inside of a method. So public Boolean return type, compatible, method name, takes another pointer account, we'll call it other. So I saw like there were a number of approaches to this, but I'm just going to do like the standard sort of if-else chain implementation. So two users are compatible if so if the difference between their ages is 10 years or less. So we could say int diff is equal to this dot age minus other dot age. So the trick is you have to use something, you have to do this or something equivalent, math.absolute value. What absolute value does, if it's negative, it turns it positive. Here's the problem that you get, right? Let's say this dot age is equal to 32 and other dot age is equal to say 45. So this is outside of, like, these two are more than 10 apart, right? If we were to calculate this without the absolute value, we would get 32 minus 45, which is equal to negative 13, greater than the difference we're looking for. But negative 13 is less than 10, right? So this would still like activate the if statement if you were to do it this way. So either you call math.abs, which, oh wow, that's thunder. Jeez. Math.abs would turn the negative into a positive, which means that this would no longer be valid, which means the case wouldn't be entered, or you would have to do something like diff is less than 10 and diff is greater than negative 10. Something like that. So we have a couple of other conditions. I'm just going to, I've changed my mind. I'm going to do them as one big long condition here. So, number 2, both must either be smokers or non-smokers. The easiest way to do this is this dot smoker equals other dot get or is smoker, right? Remember, and this was a very common mistake, smoker is private, right? So you can read it directly here. Actually, that's true up here as well. Get age. The method is, or the value is private, so in other, you have to actually access it through the methods of the class rather than being able to access it directly, which you would be able to do if you had made it private, or made it public, but it wasn't supposed to be public, so, you know. Anyway, further, the user passed as an argument must be shorter than the user whose compatible method was called. So basically, this dot height must be greater than other dot get height, essentially. And if all of those conditions are true, we return true, and otherwise we return false. And of course, if you remember the simplification that we discussed in class, you can actually remove this entire if statement and just use a return statement instead. Whenever you're returning true on the true branch and false on the false branch, you can actually blow out the entire if statement, just replace it with the expression. There we go. Now let's do B3. So, write a main method. public static void main. There we go. Main method. There was a mark for that. Wow. I'll be interested to see if that comes over the recording. It's like thunder and lightning out there. So, he's taking up the test during a thunderstorm. That's hilarious. So we make two account objects. Names don't matter. I don't know why I chose to do it that way. Terrible. So we initialize with name1, height, or age 1, and height 1. There we go. And then we initialize with the other information. These were intended to be humorous, incidentally. So, because the smoking property can't be set through the class constructor, you actually have to set it manually. Because the second user has the default value, you don't actually have to do anything. But for the first one, you do. Then I saw a lot of people do the part where they call compatible and output it. They did that on separate lines, which is kind of useless. You can just do it on one line. So you would say foo.compatible bar. There you go. Oop, there we go. So, good. So, let's go through this final question in part B. So, translate the UML diagram. So, one part that was very frequently missed here, this arrow in the middle here implies the existence of an account, or sorry, a file instance variable in the file system class. Whenever you do these sorts of things, I always recommend starting off with the smaller class and working your way up. So let's do it that way. So public class file. There we go. We have private int size. Then we have two methods, public file taking int size, the constructor. And then we have a getter, public int get size. Both of these methods were very simple. The constructor simply says this dot size is equal to size, or whatever equivalent to that you could come up with, and then return this dot size. You don't have to have this dot size. Return size also works here. Remember, this dot size is only necessary because there's a namespace conflict between these guys. If you named this something like S, then you could get rid of the this dot, and it's still valid and legal Java code. So mark for this, mark for this, mark for that, mark for that. Public class file system. We have our two instance variables given in the class, private string description and private Boolean locked, and of course the instance variable implied by the association arrow, private file f, or whatever. The name isn't given, so you can pick what you want. We had 3 methods here. Public file system taking string and string description and Boolean locked. There we go. I'm going to just adjust the width here if I can. There we go. Hopefully that still comes through on the video all right. And then an overloaded definition, which in addition to those two, takes a file object. So in both cases, we have this dot description is equal to description, and this dot locked is equal to locked. That occurs in both cases. In the case of the one where you are passed the file, you pass that on to the instance variable. But in this case, unless you set a default value for this file to indicate its non-existence, basically the idea is if this constructor is called, then the file system has no file, meaning that the file is like the value of f will be null. You don't have to say it explicitly, it happens automatically, but that's what it looks like if you don't put anything in. So we then have the format, public int format function, method, pardon me. Takes nothing. So our conditions here, if the file system is locked, method returns -1. So if this dot locked return -1, note that you do not have to say this dot locked is equal to true, because that will just, like, is equal to true is always redundant in Boolean expressions. You never actually need to state it, although you may wish to state it for your own sanity. Else, if the file system is not locked and there is no file, return 0. So if this dot f is equal to null, return 0. So a lot of people would have said something like not this dot locked, or this dot locked equals false and. This is only necessary if you don't include the else. If you include the else, then everything on an else branch implies that the first condition didn't turn out. So if this dot locked is true, then down here it has to be false. So you don't actually require that statement in your if statement. And if neither of those things are true, then we return f.getSize. There we go. Done. So minimizing redundant assignments here would mean taking this and replacing it with this passing description locked and null. So that's how you would get from 12 to 13 points on this question, is by remembering this, remembering to minimize code redundancy using this. So there you go. Good. Now, for these questions, I'm not going to like speak it out so much. Is this going to work? It's okay. I'm not going to like write the solutions down so much as just sort of talk about the code. So in this piece of code, we have the following output, right? This is what we get when we print here. So the reason that this is happening is that, presumably, well, it's given in the question, there is a public instance variable description, right? Presumably the constructor is setting it, right? Well, not presumably, that's stated explicitly in the question. When we print the object, we're not printing any of the properties of the object. We are viewing the memory address, right? So this is Java's default when you try to print an object. This back half is the actual memory address at which the object is stored. So that is what is being displayed instead of the object description strings. Why the numbers change: the memory address at which Java places an object changes each time the program is executed. That's why, well, it may anyway. That's why these numbers change, is because they're being stored in different memory cells. So how would you fix the problem? There are a couple of ways of doing it. One would be simply to state, call out the field rather than the object itself. So that's one. That's a good way. But the answer that impressed me most was define a toString method in the store class. This is far and away the better of those two solutions, because that means if you define a toString method, this fixes this problem for all points in the future rather than just fixing it here, right? So those were the two approaches to this problem. Good. So opinion diverged quite substantially on this question, and I can't really go through all of the wrong answers I got, but let's see, some of the common ones were I forget. This is the correct solution at any rate. So let's talk about C2. Here we are. There we go. There we go. So I can't set the value of the x position variable no matter what I do, right? So the problem here is that this is a namespace conflict. This, what's meant by x position here is actually the same as the argument that's passed. So under this definition, all I'm doing is reassigning the value of the argument to itself. In order to access the instance variable of the class, you need to put this dot. That's one way to do it. The other way to do it would be to go through and change the name of the argument so that there's no longer a namespace conflict between that and the instance variable. So that's what the problem was, and that's 2 ways to fix it. So there were a number of, like, this was one of the worst questions, like, in terms of, like, the correctness of student answers. This was one of the worst ones on the test. This one and the other analysis question, this guy here. So I got lots and lots of answers that were like, oh, you didn't initialize a scanner object, and that's a mistake. It can't possibly be a mistake to not initialize a scanner object. Initializing a scanner object is, first of all, something you only do if you're trying to take input from the user. There's no indication here that we're trying to take input from a user. This is just a setter inside of a method. This is just a method call. This method call doesn't work. Whether or not this is input that's been taken from the user is immaterial to the problem that we're currently encountering. So, not setting a scanner object is very wrong. Another one that I got a lot was there's no constructor in this class. There doesn't have to be. It's not actually, like, strictly required that you initialize a constructor. So yeah, aside from that, there was a lot of guesswork that ultimately didn't lead to anything. So yeah, so that is the test. I highly, highly recommend going through this video again once you get your tests back, so that you can see where it is that you made mistakes, so that you can hopefully do better on the next one. Take her easy, folks.